We are back. My name is Seth Juarez. We're at the Washington State Convention Center, the 2017 edition of Build. I have here the great Anders Hejlsberg. How you doing, my friend?
I'm doing well, thank you.
Fantastic. Before we get started with him, just want to let you know that this is live. Any questions that you have for him, just tee them up. Otherwise, I'm just going to hog all of your time, Anders.
There you go.
And he told me he did not want that. Okay, so get your questions going. I'm watching him here. How's it going, Anders?
It's going good.
So what have you been working on lately? Because I foolishly was like, oh, Angular 2 came out. And then you're like, well,
No,
sad.
TypeScript 2, you mean.
Sorry. I was just talking
Angular
about
2 came out too, but Angular 4 and 4.1 has been.
I was just talking about Angular. TypeScript 2 came
That's
out.
right.
And then you're like, well, Seth.
Well, then 2.1, 2.2, and 2.3. We're on a pretty rapid cadence now, about every 2 months. In fact, we just decided to sync with Visual Studio Code, and they're on a 2-month cadence. So we're just going to snap every 2 months.
So anytime Visual Studio Code has a release, TypeScript's also going to have a release.
That's the plan. Yeah. Yeah.
So what are the things that are being added? Because I mean, this is pretty rapid. I mean, I've never
is
heard of
pretty
languages
rapid.
evolving that fast. Is what I'm trying to say.
Well, I mean, I think for 2.0, so the big headliner there probably was non-nullable types.
Okay.
And control flow-based typed analysis, and then we did stuff around discriminated unions and like advanced stuff in the type system.
Right.
Let me see if I can remember. 2.1 was down-level async await, which is something that people have been waiting for a long time. You know, so basically allowing us to compile async await constructs down-level to ECMAScript 5 or ECMAScript 3.
Oh wow.
Yeah, and that took for us to rewrite the emitter into a tree-based transformation emitter.
Holy cow.
Yeah, but that's done, and so now, you know, we do a beautiful job of async await on any JavaScript platform now.
So let's pause there, because that to me is because when you're doing async await, you're effectively making a state machine somewhere in the background.
You have to rewrite the code into a state. You have to wrap a state machine around the code, which, when we did this work originally in C# was not easy, but at least on the .NET runtime, you know, you have go-to statements, so you can sort of go to the end, return, and then from the top you can come back in and go to where you were, right? But there are no go-to statements either in JavaScript. So now you have to sort of wrap this funny while switch statement around the code and do all sorts of interesting transformations, and then you got to provide what we call a trampoline on the outside that basically bounces control back. So it's almost like a little message pump, you know, but it's all very pretty, you know, and we can use generators if we're on an ES 2015 platform, but otherwise we got to rewrite it all the way down, you know, so.
And that's, I mean, to me that's a very impressive, right? Because it's like you're working with you got it, or if you said it goes down to ECMAScript 4, you said?
No, ECMAScript 4 never shipped.
No, getting everything wrong today, Anders. So async await works all the way down to ECMAScript.
All down to ECMAScript 3, which is the lowest target that we'll do. But ES3 and ES5, we don't have generators or anything.
Right.
So we basically got to completely rewrite it.
I'm just trying to think of like the mathematical way of proving that this will always work under every circumstance.
Well, the
How did you do that?
transformation the theory behind the transformation is actually well understood. It's like continuation-based programming, and there. So it's not hard to know what to do for the rewrite. It's just there's a whole bunch of corner cases you gotta because you gotta be prepared to, like, let's say I'm in a switch statement and I'm in a case and I'm 3 levels into a sub-expression, and now the user uses the await operator in here, and now you got to return right there. How do you arrange for that to happen, and how do you then arrange for control to come back to that point? You know, when you next get when the next piece of the async workflow completes, right? That's tricky.
Yeah, and you mentioned that you changed into a tree-based emitter, right? What was it like before? Was it just looking at TypeScript and emitting things at
sure.
the point?
It was always tree-based in the sense that we always do a walk of the syntax trees, and then based on that we do the emit. But it used to be that it just went straight from trees to text. So it would literally just walk the tree, and as it was walking, it would emit text.
I see.
Now what we do instead is we have rewriting phases where we basically move from, for example, we erase all async await constructs.
Of course.
But then we erase them to ECMAScript 6 or ECMAScript 2015 constructs like generators. And then if you don't have generators, then we have another phase that can erase generators and turn them into ECMAScript 5 or ECMAScript 3. So it's based on phases now, right?
I see.
And so now basically it works by taking an input AST, abstract syntax tree, and turning it into another tree. And then you can feed that tree into the next phase, right? So
my goodness. So
yes.
I'm thinking
because
about this.
otherwise there are just too many things to keep track of at the same time.
When you're writing these things in TypeScript and you're compiling or emitting, how do you know the target browser? Do you have to tell the compiler, I'm going to target
there's
this?
a dash target switch that you use in the compiler.
Fantastic.
Yeah.
So here's the question. One question coming in. First, once again, thanks for creating C#. Where do you see yourself going once TypeScript has grown big enough to not require your help anymore?
I try to not think too far ahead about these things. I try to live in the product that I'm in, and I just devote myself fully to that, right? And so TypeScript right now is still got some growing to do, and so I'm committed to that, and then we'll see. If you told me well, I guess I've been doing this for more than 5 years now, but if you told me 7 or 8 years ago that, you're going to be writing compilers and you're going to be writing them in JavaScript, right? I was like, what? It's not going to happen. But you never know what opportunities come along, right? And this has been so much fun, and it's wonderful to see the reception that the product has gotten.
No, I mean, it's it's really taken off.
Yeah.
I mean, this is being used everywhere.
Yeah.
Now, did you imagine it would take off this fast?
Well, it hasn't been that fast, actually. I mean, it's really quite remarkable. You look at our NPM download numbers; it's very steady growth. It's just the law of big numbers now. We've gotten big. I was hoping. I always felt that there was a there.
Yeah.
When we started, right?
Sure.
But you never know.
Now he's modest, and he won't tell you this because maybe he doesn't know. But the most popular video we have on Channel 9 is you introducing TypeScript.
Is it really?
Yeah. I mean, it's the most viewed thing. Like, if you look at most viewed ever on Channel 9, yours TypeScript one is right in there.
That's great.
Which is pretty amazing. And
That's
what he
fun.
also won't tell you is this guy is still committing code. It's not like he's like, hey, let me come in here and pontificate. You sit in a team room next to the PMs and the devs, and you're committing code.
No, I write a lot of code, yeah. I write more code now probably than I've written in all of the prior years, really. I mean, I wrote I still maintain the type checker, and I wrote huge portions of the compiler.
And this is all open source, and the compiler is written also in JavaScript.
In TypeScript,
TypeScript,
Yep.
That's awesome. So you mentioned 2.1, async await. What was happening in 2.2?
2.2, probably the highlight there was, in 2.1 there was another thing called map types, which is pretty interesting because this is like we're really like capturing some whole new grounds in the type system and the ability to reflect whole patterns that I've never seen a type system be able to do before. 2.2, I'd say the highlight there probably was mix-in classes, support for the ECMAScript mix-in pattern. And then we just shipped 2.3, and so we're just like going all the time.
I'm a traditional C# dev. I started in C# in 2002 before it was even ready to go because I wanted to move away from VB6. And so there's some of the patterns that you're describing, like mix-in and the one you described before, I'm not familiar with. So why don't you help me understand them for those that are watching?
So map types is effectively the ability to describe transformations that APIs do on known transformations that they do on a type. For example, imagine you have an API that can take an object and return an object where all the properties have been made into observables.
Okay.
So it's sort of an observableify method, right? Where you walk over the object, and for each object you make a corresponding property in another object that is observable.
Is it like the map, like the functional map?
So it's sort of like a mapping applied over the properties of a type.
Okay.
And you can now express that in the type system, and the inference engine can even reverse infer from that. And it turns out that a lot of JavaScript APIs do these patterns, and now we can faithfully represent them declaratively, which is, and therefore we can give you better statement completion and better type checking and just follow along when you're doing sort of these higher level things in your APIs.
And the thing about JavaScript is that the first JavaScript thing I wrote, I must have been like 14 years old, and it was an image hover, right? It was the first thing I ever wrote, but the simplicity of the language makes it infinitely powerful to do some really impressive things. I've never heard about map types. Is this something in the
No, but this is not a JavaScript thing. I mean, the concept of doing mappings, treating objects as bags of properties and then doing transformations on the properties of an object, that's something that people do in JavaScript. It's like bread and butter, right? But our job is to take all of these bread and butter patterns that people do in JavaScript and then finding representations of them in the static type system world so that the tooling can follow along.
Oh my goodness.
You know, and so that's some of the ground we captured there. We did some more work in 2.3 to better support some of the patterns that Vue.js does in creating views. So there's still a lot of stuff that we can explore here. You know, we're not done yet. Mixing classes, you mentioned.
Let's talk about that one next, and then I want to get into Vue because Vue does something very different than what I've seen some of the others do.
Sure.
And so let's talk about mixing classes and then get into Vue.
Well, mixing classes is just this pattern of having a function that takes a constructor function and then mixes in some additional functionality and returns the mixed in version of the constructor function. So it allows you to take, like, say, printability and mix it into any arbitrary class, right? So it's, in a sense, it's a form of multiple inheritance that you can do and that you can represent in JavaScript's prototype pattern. And so people do that, and it's gotten a lot easier to do in ECMAScript 2015 because classes are expressions. So a declaration of a class isn't really that you can have class expressions, and because you can have class expressions, you can do these transformations, and that's how people do mixins.
So I'm trying to understand because maybe I'm extra tired or something.
No.
But what am I actually passing into the constructor? Is it additional functionality? Is it a function? Is it a class of some sort?
It's more like, say you have a function called make printable, and you pass to it your class, and it returns to you a version of that class that now has, say, a print method or whatever.
It's like a different type of inheritance, polymorphism.
But it's represented, but because in JavaScript, everything has, I mean, that's one of the things that JavaScript really got right, is that functions are first class.
Yes.
And because classes are represented as constructor functions, they are also first class, and therefore you can pass a class as a parameter and operate on it and return a new class,
and because
which is really like a new constructor function, right? But of course we have to understand, again, in the type system what's going on so we can statically analyze and so that's another pattern that we captured in TypeScript.
So if I'm capturing this right, there's a ton of things that just JavaScript developers have been doing forever that we've never really thought about in a static way that we now have to somehow support.
Sure.
Okay.
I mean, our job really is to formalize JavaScript's type system because JavaScript has a type system. It's just never, in a sense, been formalized in a static sense, right?
So let's get to some questions because I've been hogging your time like I promised I would. Will it be possible to use the new async generators in ES5 or even ES3?
Yes. That's what we shipped in TypeScript 2.1. So it's in the shipping product. Yeah.
Fantastic. Next, great to hear from you. It would be great if you could give a few examples where AI is being used in Visual Studio itself, and how does Rosin help in any AI efforts, if at all any. Are you involved with AI at all?
I'm not really involved in our AI. I mean, obviously there's a lot of AI you can apply to code and recognize coding patterns, and then maybe connect it to, you can sort of recognize from what's going on in the code, where might we be able to find on GitHub similar patterns or whatever. And it's stuff that's being thought about, but there's nothing specific that I can.
Like, I've always wondered if it would be, like, I'm a machine learning guy, is where I come from. It'd be cool to see like ASTs and compare those to others and see if code actually belongs in some kind of grouping. Like how to detect malicious code, for example, would be really
cool. That would be cool.
All right.
That would be cool.
From Shrike, will TS ever target WebAssembly if it makes any sense at all? Thoughts of WebAssembly future?
Well, so WebAssembly is interesting and also in many ways misunderstood, because WebAssembly is about emulating native code inside a JavaScript VM. So really, inside in WebAssembly, it's almost like it's like you're emulating an x86 processor,
Right.
or the equivalent of it, right, inside the JavaScript VM. So any mixing of TypeScript, and it's not really, you're not talking the same language. You're at different meta levels here, right? And, well, if we had to run TypeScript inside WebAssembly, well, then we would need first to have a JavaScript VM within the JavaScript VM. Because you're at the native code level
And then
in
type
WebAssembly.
slows down, right?
Yes.
Because
And
it's inception,
yeah,
right?
yeah.
All the way down.
So really, WebAssembly is about running native code in a JavaScript VM sandbox. That's really what that is about.
This is a good question from some random dude. What's the next big thing you'd like to get into with TypeScript?
Oh.
Well,
I think one of the things that we're exploring right now pretty heavily is how to reuse all of the intelligent infrastructure that we built for TypeScript for plain JavaScript.
Okay.
So in TypeScript 2.3, we shipped a new flag called check.js that you can turn on in your TypeScript in a JavaScript code base. All you do is drop in a config file with check.js enabled, and then, or you have an environment setting in VS Code or whatever, you say, yeah, sure, go ahead and check my JavaScript files. Then we run the same type checker that we have in TypeScript, but we run it in a much more conservative mode.
in a looser sort of way.
It's looser and more conservative in the sense that in TypeScript, if we're unsure about something, we whine and make noise, right? In check.js mode, it's more like, hey, this could actually be true, so let's not make noise. But there are a lot of things where we can see this is definitely wrong.
Yeah.
Why don't we make some noise about that?
And so that's what you're looking to do.
Well, that's what we're doing in 2.3.
Okay.
And the reason that we can do a lot of it is that modern JavaScript is actually quite statically analyzable. You know, like ECMAScript modules were designed so you can statically analyze what gets exported from a module and imported so that VM startup time could be better. And
Sure.
Classes, we can see the shape of a class because you're declaring all the methods, right? And so we sort of know the top level structure of everything. And we could check a whole bunch of stuff. Plus, because we have now in TypeScript 2.0, did a bunch of work to automatically package declaration files and publish them on NPM in the @types namespace. We can actually auto-provision type information. So we can notice in your node modules folder, oh, look, you're using jQuery and Lodash. Let's go fetch the types. Let's cache them locally, and then let's check against them.
See if you're using them right.
And yeah, so all of a sudden, we can light up and do a whole bunch of stuff in your JavaScript without you, just for free. But then, of course, you can add some JS doc annotations in comments, and then we can pick up on those, and then we can do a little bit better. And then you can maybe decide, oh, I kind of like all this. Maybe I should just do real type annotations and go to TypeScript. You know what I mean? So you can set the dial in many more places, and the glide slope in has gotten a lot shallower, right? So it's the barrier to entry is much lower now.
And that's kind of awesome because now it's like, I don't know if it's just a better linting.
It's much better linting because it can do semantic analysis, right? Linters typically are restricted to very local coding patterns, and they don't do type-level semantic analysis. And we can do that, obviously, because we're a type checker. So
keep your questions coming. Obviously, we have the great Anders Hejlsberg. We have 15 minutes with him, so please get your questions in. Let's talk a little bit about some of the newer JavaScript frameworks and what TypeScript is doing to get involved. The one that I've seen that is really interesting to me because it does what we were told not to do, but it makes sense how they're doing it. Vue.js, the .vue files incorporates both the HTML, the JavaScript, and the CSS in the same file, which is tremendously interesting, right? Because at first we were told not to. Remember, we used to be, let's put our JavaScript here, let's put our HTML here.
It goes back and forth, the pendulum,
And but now this is all in the same file. What kind of things are we doing to help support that?
Sure. So the notion of having markup and code mixed, as you say, is not new, right? In an HTML file, you have markup on top, and then you can have script tags.
Sure.
And then in React and JSX, you have JavaScript on top. And then you can arbitrarily switch between the two all the way down, and that's how JSX composites, right? And it's actually really cool. Vue, allows you to either Vue is actually not particularly prescriptive, but a lot of people use it where they put, like you say, your markup, your script, and your CSS in one file that defines a component. Now, in order for us to be of use there, we need to effectively then we need to composite the language service, right? I mean, we need to have a language service that can do all of those.
Right.
And there's a community project called Vetur, V-E-T-U-R, that is an add-in for Vue, and we've helped out with that a little bit. And it basically starts with the HTML language service, and then proxies onto the TypeScript language service inside a script tag. So basically you can get statement completion in your script portion, and also statement completion in the markup portion within the same file. And then further, to better support Vue, Vue has some interesting patterns. When you create new components, you do it by calling the Vue constructor, Vue.extend, and then you pass an object literal that can have different sections in it. It can have a props section and a data section and a computed section and a methods section. And then it munges that information and builds a prototype and hooks up a bunch of notifications. And then it sort of regurgitates it back to you as the this type in your methods, right? So the this type in your methods is actually a combination of properties coming from Vue itself and from your data property and from your computed properties, sub-properties.
Right.
Now, the work we did in TypeScript is to allow you to express that declaratively in your type declarations of the constructor, so you can specify now what transformation should be applied to the this type in such that we can
make inference,
so that when you're sitting there typing inside the methods section of your Vue component, you see all of the properties that came from your computed section and whatever. It's really kind of cool.
It's not a trivial...
it is not. That was not a trivial thing to do. No. We had to scratch our head a while on that one, but it's in there, and it's nifty.
And that's the interesting thing with this is everybody, JavaScript, we always never know what this is, but we do in TypeScript, right, which is great. What is this?
What is this? You're right. That is.
Awesome. Some more questions. Why not convert JS directly into ASM, make JS code like an instance of C, C++? Why not?
Well, that is effectively what a VM does. Right? And so no one today runs JavaScript by interpreting it in the classic sense. All of the execution engines, all the JITs, turn it into native code. Now, you could do that ahead of time, you could argue, but it turns out that when you're doing it ahead of time, there are certain dynamic optimizations that are not possible. You can't really notice what the hot path is, and you can't. So there are things that jitters actually. So it's been explored. But you would effectively have to link in a JavaScript execution engine and a garbage collector and whatever. So you can't just turn it into ASM. It's not that simple, right?
Okay. Next question. Do you sneak into some C# design meetings, or have you put it behind you?
Oh, no. Yeah, absolutely I do. Yeah, we have design reviews. I'm not in every C# design meeting now that I used to be, but we do regular design reviews. And certainly the nullable type feature, there's a lot that C# can learn from the work that we did in TypeScript to introduce nullable types, and a lot of that same theory is how C# is progressing with this feature now.
Remember, explain the nullable type thing, because this is really interesting, because one of the crazy things about the languages that we sort of live with is there's this problem of null.
Yes.
What were you doing to make it a little bit better in TypeScript? Because we made a video on this together where you showed it, but I'd like you to introduce the audience to it. And how might that translate into C#?
Sure. So the problem of null goes back since the beginning of Tony Hoare, beginning of time, his $1 billion mistake, or as I joke, the $2 billion mistake in JavaScript, because we have null and undefined, right?
Right.
Basically, by the time we got to TypeScript 2.0, we sort of had set ourselves up with a lot of the capabilities in the type system that we needed. In particular, union types is like a key enabler for us. The one thing we didn't have was control flow-based type analysis, and that was some of the work that we did there, because it turns out that when you're doing non-nullable types, you really have to be able to analyze what statement and expression constructs get rid of the nulls.
Right.
Like when you're inside an if x not equal to null if statement, you certainly want the null to disappear from x's type.
Right.
So you want to dynamically change the type based on control flow.
Right.
So have control flow guide your types, right? And that piece we had to go build for TypeScript, which we did in 2.0. And then once you're there, then it's actually pretty simple in the TypeScript sense, because we simply said that previously null and undefined were valid values for any type, and therefore we couldn't analyze because you could assign it anywhere, right? Now, in strict mode, we say null and undefined are not values of any types, except null is the one and only value of the type null, and undefined is the one and only value of the type undefined.
Right.
And then you can union them in. So if you want something to be nullable, you could say string or null.
And you have to explicitly say,
and you have to,
this might be null.
Yes. Or this might be undefined, or it might be both null and undefined, or it might be neither.
Right.
Right? And now that we know that, then we can simply narrow your type. Well, simply, it's not that simple, but we can then, guided by control flow analysis, narrow your types based on what checks have preceded. And that's also the enabler for this feature called discriminant union types, where we narrow the type of an object with a discriminant property. So when you're in a switch case for that particular value, then we can narrow it down to that variant of the type, right? Based on the same logic.
Right. And C# could...
And C# is a little bit different because C# doesn't have union types.
Of course.
So some of the things we do, they can't do, and they sort of have to track it in a sideband, you know, the notion of whether a type is not. But in principle, all of the control flow-based type analysis is the same. Okay. Yeah.
All right, more questions. How fast should developer update their versions of TypeScript with respect to the TypeScript version releases?
Well, I mean, ultimately that's up to you. I will say that we are very, very serious about maintaining ship quality in our master branch at all times. Okay. We take no pull request unless all the 50, 60,000 tests we have pass, and new tests come with new features come with new tests.
Right.
We don't take them if they don't. So master is always good, and the nightly build. Really, a substantial portion of our user base run with the nightly build. And that means we're really, in a sense, perpetually in beta. You know, so, no, but that means our quality, if something goes wrong, we hear about it immediately, and we fix it immediately. So,
which is kind of good too, right?
Oh, yeah, no, it's great. So, like I said, a lot of people run on the nightly builds.
And this brings us to the next question from Christian, which I think is apropos. Does TypeScript have a no-breaking change policy like C#, or will features be declared obsolete or removed in future versions?
Yes, it's this is of course an issue that we think about a lot, and wrangle with a lot, and as we get more and more adoption, it becomes more and more relevant, right? As a rule, we try to not break people's code, but of course, our job, in a sense, is to complain about their code, and every version introduces more type checks.
More complaints.
And therefore, more possible errors. And therefore, we're sort of on the name of the game is to break your code,
now,
right? In a sense, right? So the way we think about that now is, and we actually spend a bunch of time thinking deeply about this, is that it used to be that we were afraid of introducing certain new checker features, even though we felt that if we had a green field, we would do it today.
Right.
Like say nullability, right? Yeah, absolutely we do that, but it's obviously a breaking change because we're going to report more errors on your code. So now what we do is we tend to put these features under a flag, but then of course the question becomes, what should the default value of the flag be?
Right.
Should it be on or should it be off, right? And of course, as we accrue more flags, who knows out of these 10 flags representing each of the new, which one should be on. So now we have a new master flag called strict. And strict establishes the default for a whole family of checks that we feel are best practices. So now you can either if you opt into strict, then we may break you.
Yeah.
But then you can manually opt out the one feature that broke you.
Yeah, but here's the thing.
But you can basically anchor yourself either to the latest and greatest
Right.
or to a fixed point in time now. And that gives you some better assurances, and then that in turn allows us to be more flexible about what we put in the product.
And the thing is, like, you told me this, when you added the null checking, it broke your own code.
Oh yeah.
Like, it's not like this is
These
something
were
that
good breaks. I mean,
you weren't immune to this.
No,
you were
no,
telling
no,
me that there were some interesting things like, oh, I didn't see that,
Yeah.
right? And
Oh,
so
yeah.
I like how you're saying TypeScript's job is to effectively not break your code, but see where you've broken your own writing code.
No, it's telling you about how your code is broken, right? But
Awesome.
yeah.
All right, next one. Great to see you, Anders. You're the coolest humble dev guy that ever. Juan Manuel likes you.
Oh, thank you.
Yeah, very
Appreciate
nice.
it.
All right, next one. Will the work to use TypeScript language service features in script tags for Vue also to use TypeScript in script tags in Razor syntax?
In theory, yes, but someone needs to do the work, to integrate the two. We did in 2.3 formalize a language service API, so it's now possible for the community to get in there and build this stuff. So
Right.
I mean, if someone did a pull request for that, we'd certainly look at it.
With unit tests.
There you go.
That's what he said. All right, Elias asked, what are the most exciting features you see coming in TypeScript? Tuples, maybe?
Oh, tuples are already in there.
Okay.
Yeah. I actually think at this point, one of the things I'm most excited about now is that we have so much infrastructure in place that we can start to build some really cool refactorings and UI features.
Oh my goodness, that's right.
We've just started in on quick fixes, and we're building way more refactorings. We're adding a language service API that allows people to build refactoring, so we'll see the community pick up on this.
Wow.
So I think we're about to start reaping a lot of the rewards for all of this work that we've laid down.
Awesome. This is an interesting question, and one that we had at the last build that has to do with minification and maybe even tree shaking. When will TypeScript handle asset minification? Is that part of TypeScript, or is that something that's orthogonal to what you're doing?
It's, I think the way we think about TypeScript is that we bring two things to the table. We bring great tools enabled by static typing, and we bring transpilation. Those are sort of our two key things that we know that we're going to do.
Right.
There's a whole bunch of other stuff we could do, like tree shaking, optimization, minification, but we got to be careful about being too many things in
Right.
one tool, right? Because then we lose track of what is our mission. I think we work really, really hard to fit into the JavaScript ecosystem tooling pipelines very well. So
Right.
we reach out and we work with RepPack and Rollup.
And he's here, one of the
yeah,
gentlemen
no,
that
and we
works with
Sean.
awesome guy.
Yeah, no, I chatted with him yesterday. So we see that as important,
Right.
to not try to like own the universe, but rather to be really, really good about the things that we do.
And now we have 10 seconds. Where can people go to start learning TypeScript and using it? It's a wonderful language.
TypeScriptLang.org.
Awesome. Thanks
It's
so
all
much
there.
for spending some time
Yeah.
with us. Thanks so much for watching. We're here at the Washington State Convention Center for Build 2017. We will be back after this little break. Take care.